Welcome back, children. We'll move on with the chapter 6 of your NCERT class 11. That is work, power, and energy. Such an important chapter. Almost every chapter you hear the word energy. Along with that, work, sometimes power. So, the concepts, formula, relation that we develop in this chapter are quite commonly used in almost all chapters of physics from a very fundamental level to the research level. The word energy is a common term. So in CET in NEET also, in various chapters, we use the concept of energy work to simplify problems. One problem can be solved in many ways. One of the ways is the concept of energy. So we'll start with some of the important ideas related to work. Work you learnt in regular class as a product of force and displacement. That too, dot product, work W, force F, displacement S. And the work done depends not only on the value of force, value of displacement, but also their directions. And the directions taken care of by the dot product of two vectors. And you learnt dot product in chapter 4, that is f dot s, the value of f, value of s into cosine of the angle between them. How do you analyze this? For example, there is a body laying on a surface here. You apply a force in a particular direction, say f, making an angle theta with respect to the direction of motion. The body will be displaced from here till here. By that force applied, we will measure from the center of mass of the body. Displacement is s. In the direction of displacement, the force is not acting, making an angle theta with respect to the direction of force. Displacement. So you resolve the value of force into two values. One, the horizontal value, that is say x-axis. The other, vertical value, say y-axis. What is horizontal component of force and what is vertical component? If you resolve vector into two values, one horizontal component, the other vertical component, as I explained you, the horizontal component, this is adjacent side, and vertical component is opposite side. What's opposite? Normally hypotenuse into sine theta. We have learnt it several times, several hundred times. So adjacent side, hypotenuse into cosine of the angle theta. So the value opposite is say vertical value or y value, sometimes vertical value, that is hypotenuse f into sine theta. It should be there with you always. And horizontal value fh, that is f into cos theta. Whenever you see the resolution, horizontal value hypotenuse value into cosine and vertical hypotenuse sine. Actually, a part of the work, force F, is only pulling the body in the direction of displacement. So, the work done must be found as displacement times component of force in the direction of displacement. That is, we analyze work as displacement times component of force in the direction of displacement. Component of force in the direction of displacement. Or you can analyze this way also. Component of force times component of displacement in the direction of force. We can write that way also by resolving displacement in the direction of force. Either way, you arrive at the same answer. No problem with the idea. But here, since theta is the two cosine, theta is variable, that it can change value from 0 degree to 180 degree, 180 to 360, like that will come across different situations. So I can come up with some special cases. Case 1, if theta 0 degree, theta 0, in that case cos 0 1, so the work done is maximum. In this case, the maximum work is force times displacement. And in the case 2, if theta 90 degree, means force and displacement are perpendicular to each other, 90 is 0, that's why the value of work that equal to 0, because cos 90 is 0. And the third case, if theta is equal to 180 degree, Then cos 180, minus 1. So work is minus F dot S. Value wise, when cos 0 or cos 180, value wise work is same, but the effect of that work will be different. What is that? What is the example for positive work? For positive work, case 1, this is the situation. There is a body lying on a surface. It's a heavy box. You're pulling it along the horizontal. Body is moving in the same direction, displacement as well as force in the same direction. In this case, the body increases its speed continuously. Continuously, the speed increases. So this force F produces, remember, produces positive acceleration. Positive acceleration. In the second case, when the force is perpendicular, there is force. Motion is horizontal, force is perpendicular to that. Then the work done by that force is zero. Body is moving because of some other reasons. But the work done by that body is zero. This is the case with a man carrying a suitcase in his hand. He is applying force to balance the weight, not to move. Once he holds, it becomes the part of his body. So when he walks, he's just walking, holding it means walking, displacement horizontal, force vertical. Angle between them 90. Work done by the man on moving the suitcase 0. Now, what about negative work? Negative work. When body is moving to the right, say displacement right, force left. What is the angle between them? Angle between the two, see here, force displacement are in the opposite direction. What is the angle between them? 180 degree. Here, since force is acting in the opposite direction, the displacement goes on decreasing. So an example for deceleration, it produces this positive acceleration, first case. This is negative acceleration, also called deceleration. Negative acceleration. Negative acceleration implies speed decreases, finally body comes to rest. So work done negative implies the speed decreases. Whether speed increases or decreases, the work value same but the effect different. That's it. Positive acceleration, positive work. Negative acceleration, negative work. Not only for 180 degree negative work, if the angle here, if theta is more than 90 degree, or if I write this way, if theta lies between 0 degree and 90 degree, work W positive. And if theta lies between 90 degree and 180 degree, work is negative. Negative in the sense a component of force acts opposite to motion, producing deceleration. Speed ಕಮ್ಮಿ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. If the component of force is in the direction of motion, component of force, a part of force ರಿಸಾಲ್ವ್ ಮಾಡಿದಾಗ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಮೋಷನಿಗೆ ಬಂತು ಅಂದರೆ ಪಾಸಿಟಿವ್ ವರ್ಕ್, ಪಾಸಿಟಿವ್ ಆಕ್ಸಿಲರೇಷನ್, ಸ್ಪೀಡ್ ಇನ್ಕ್ರೀಸಸ್, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇನ್ಕ್ರೀಸಸ್. ಸೊ ಆ ಥರ ಆಗಬೇಕು ಅಂದರೆ ಫೋರ್ಸ್ ಮತ್ತು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಬಂದ ಆ್ಯಂಗಲ್ ಬಿಟ್ವಿ ಮಸ್ಟ್ ಬಿ 0 to 180, 0 to 90. 0 to 90 ಇದ್ದಾಗ ಕಾಂಪೋನೆಂಟ್ ಆಫ್ ಫೋರ್ಸ್ ಇನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್, ಸ್ಪೀಡ್ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತೆ, ಪಾಸಿಟಿವ್ ವರ್ಕು, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ. ಇಫ್ ದಿ ಫೋರ್ಸ್ ಈಸ್ ಆಪೋಸಿಟ್, ಆ ಕಾಂಪೋನೆಂಟ್ ಆಫ್ ಫೋರ್ಸ್ ಇಸ್ ಆಪೋಸಿಟ್ ಟು ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್. ಆ ಥರ ಆಗಬೇಕಂದ್ರೆ ದಿ ಆ್ಯಂಗಲ್ ಮಸ್ಟ್ ಬಿ ಬಿಟ್ವೀನ್ 0 degree, 90 degree ಆ್ಯಂಡ್ 180 degree. In that range, component of force is opposite to displacement, work done is negative, deceleration means kinetic energy decreases because speed decreases. This is how you analyze, right? And we'll see some of the important cases related to this. And since it is a vector product, dot product of two vectors, vector in component form, you have learned vector in component form. For example, there is a vector. I have explained this in detail several times. I have taken specially dedicated classes for this type of discussion. This x-axis and this y-axis, the angle theta made by the vector, say P, vector P. Vector P is represented as P of x comma y. mathematics, ordered pair. What is x value? This is x value and this y value. Y component, x component. And how do you write vector p? Vector p is written as xi plus yj, right? And the value of vector in 2 dimension, 3 dimension, x, y, z, 3 axis you consider. It's just extension of one term, that's it. xi, yj, zk. And the component value x square plus y square, because opposite square, adjacent square, that's it. And here, what is I? How do you read this? Vector p has component x along y-axis or x-axis. I implies what? Unit vector along x-axis, along x-axis ಅನ್ನೋ meaning ಬರುತ್ತೆ ಇದಕ್ಕೆ. If I write j is along y-axis, ನೋಡಿ ಬರೀತೀರಾ. Now, if I write this for displacement vector r, if I write xi plus yj displacement, or if I write s or x displacement x, or yes displacement s, xi plus yj, what is the meaning of this? Both are same. X displacement along x-axis, y displacement along y-axis. J-axis means y-axis. So component of r or component of s is along x-axis xi, yj. Using them we write magnitude, means value, that is x square plus y square. Now, since force is, work is a dot product of two quantities, force and displacement. If I write work as F dot S, and F is given in terms of component form, some Fxi plus Fyj, some value, numerical values will be given normally. We will see such problems. And yes, already I have written as xi plus yj. How do you write this work now in terms of dot product? You put for fxi plus fyj dot xi plus yj, that's it. Okay. Now you use this idea. You have learned in 4th chapter that dot product of two vectors is 1, j dot j, that is equal to j dot j, and that is equal to k dot k, that is 1. If I write I dot j, angle between I x-axis, j y-axis, angle between them 90, cos 90, dot product of cos 90, and that value is equal to 0. That is equal to I dot k, that is equal to j dot k. Because you have defined dot product of two vectors, say a dot b, value of a, value of b into cosine of the angle between them. According to this formula, we find this. Between x-axis and y-axis, theta is 90 degree, cosine of the angle 0. When the angle is 90, cos 90 is 0. If angle theta is 0 degree, cos 0 1, that's it, students. When cos 0 is 1, we write maximum value for a dot b, value of a into value of b. So I dot I, value of I 1, value of I 1, in cosine of the angle 0 1, so all 1, so the value is 1. That's why I dot I1. Same is the story for j dot j, k dot k. Whereas for I dot j, value of I 1, value of j 1. What is cosine of the angle? 90. What is cos 90? 0. This term 0, that's why the value is 0. Like this you learn. That's one case. Now, how do you find the dot product of two? For finding dot product, you have to multiply the components, regular multiplication. You multiply I component fx with xi yj. First you write fx into x, I dot I, you write this way, plus fx into y, I dot j, plus second component j, that is fy times x, j dot I, plus fy times y, j dot j, that's it. Now you have learnt already what is I dot j. I dot j is 0, I dot I 1, j dot I also 0, but j dot j 1. That's why you write fx x into 1 plus fyy into 1. The other two terms 0. So final value xfx plus yfy. Like this you do multiplication. They'll give you numerical values. You put the values, substitute. Put the values here or do multiplication this way. This way you do multiplication, find the value of work. That's it. There's one thing you have to remember, the extra thing for CET NEET. One 2-3 times practice ಮಾಡಿ mind literally. Now we'll see how the numericals will be. Yes, children. Now an example for dot product of two vectors. How to evaluate dot product. Let's read the problem now. 8th one. A body is subjected to a constant force given by F. I means 1I plus 2J plus 3K Newton. It is three-dimensional for equation x, I, j, k, 3 axes. I have shown for 2 axes. Now continue with the third one. The work done by the force in moving the body through a distance of 4 meter. Which direction? Z-axis. You are moving it along Z-axis. Force is along 3 axes, has been distributed along 3 axes as 1I, 2j, 3k. So first of all you list the given 1I plus 2j plus 3k. This is force. And what is displacement? I write displacement vector. It is 4 along z-axis. 4 along z-axis implies what? 4 z-axis k, I, j, k, I x-axis, y, y-axis and k z-axis. Now what is work? Work is force into displacement. Force into displacement. What is force? You write 1I plus 2j plus 3k times or dot 4k. You multiply the components. 4 times 4 into 1 is 4 I dot k. You need not do this calculation because already you are familiar with I dot k 0. You can write 0. As is the first one, I'll do 4 2s are 8 j dot k and 4 3s are 12, that is k dot k, k dot k. So I dot k 0, j dot k 0. I explained you why. So the rest is you have 12 times what is k dot k? K dot k is 1. That's why it is 12. What is unit of work? SI unit is joule. That's why it is 12 joule. Or option B. Like this we'll try. Now we have one more, a similar one. Now look at this. A body has a velocity v 2I 5j. Value 2 in meter per second, he says 2 meter per second along I and 5 meter per second along j. Instead of giving total value, he gives the component split up value. It has got some value 2 meter per second x-axis, 5 meter per second y-axis at a certain instant. Then kinetic energy 1.74 joule, mass of the body is. Kinetic energy formula I've been learning from high school, so I can continue. The problem bar here is 22 in the list provided to you. We have sent you a list of problems. In that students, nodi v, first year students, v, it is 2I plus 5j. This is the velocity. Now how do you find the component of velocity? Value. What is magnitude of velocity? Magnitude of velocity is square root of, this is adjacent value, this is opposite value. So how do you find total? 2 square plus 5 square. You practice this. And the total were 2 square 4, 5 square 25, 25 plus 4 is 29. So the value of v, you just write v only instead of modulus 2 lines and then arrow. ಇವೆಲ್ಲ ಬರೆಯೋದಕ್ಕಿಂತ just write v, that is 29 meter per second. Why did you find velocity? Because kinetic energy, been learning from high school, half m v squared. Since it is v squared, How do you find V square? V square is 29, that's it. You want mass, that's why it is 2 times kinetic energy divided by V square. So 2 times what's kinetic energy? Kinetic energy is 1.74 divided by velocity 29. So m that equal to, will multiply 4 2s are 8, 2 7s are 14, 2 1 plus 1, 3. It seems to be a bit complex calculation, but if you come across calculations like this, there will be some trick need to identify. How to do? Start regular division. If you if you identify 2 digits, answer done, because no, option 1 3, option B 4, option C 5, option D 0.12. If you identify just 1 digit, answer done. So I do regular division. I can't divide 3, that's why I put 0 point. 0 point means 34. It becomes 34. Alway. You just think in mind like this. You think in mind like this. Do simple division. In mind only you can do. If I put down, this is 34. 34, 34, 24, 9 ones are 29 ones are 29. So 0.1 is only in one option. That's why you can go to option D. That's it. But if you continue, 29 is 29, remaining is 4, 5, 29 plus 5 is 34, that's why you bring 8 down here, so 58, 29 twos are 58, see how simple it is. It seems to be a bit complex, but if you solve one step further, definitely will identify the answer, exact answer, 0.12. That's how the values normally chosen in CET NEET. You need to think a while. You don't get frustrated or confused, thinking complex calculation ಆ ಥರ ಏನು ಮಾಡೋದಿಲ್ಲ. That ನೀವು ಒಂದು step if you try, you can easily solve, right? We'll move on, students. Okay, students, we will see another one related to SI units. Which of the following one that is different from the other C's? Of the following, the one that is different from the other C's. So it's based on the quantities which you learn in second PUC, which means class 12 syllabus. Because Coulomb, Newton first, okay, Coulomb and Farad, Volt come in second year course, right? But you just first year students just listen to it and leave, will learn second year. Anyway, going to write CET in it's after second PUC, you will learn it again. And first year, second year students can easily solve this. What is watt? Watt is joule per second, rate of doing work. Rate of doing work unit joule, rate of doing work per time. So time unit is second, joule per second into second. Second cancels, so the unit is joule, unit of work. Coulomb, Coulomb, SI unit of charge. Coulomb means ampere second according to the SI system. Because we define it using current definition, rate of flow of charge is current. So charge is current into time, current ampere, and time second, into volt. What is volt? Volt is joule per coulomb. Joule per coulomb. Joule per coulomb. So you can easily simplify it to write this way. See, ampere second into joule by coulomb. See, coulomb, ampere second cancelled here. So you are left with the unit joule only. Come here, Newton, unit of force. Meter, this Newton meter itself joule. So all the three are same unit wise. But the last one, Coulomb we can write ampere second. Farad actually unit of capacitance, which is a ratio of charge to voltage. Charge unit Coulomb, and volt unit is volt, potential difference unit. Coulomb is ampere second. And what is volt? Joule per coulomb. So you can write coulomb divided by joule per coulomb. That per coulomb comes to numerator. So the value ampere second into coulomb square divided by joule. Totally, coulomb doesn't get cancelled here. So value is totally different from joule. First three options, joule, but this is different from that. That's why you go with the option D, which is different from the first three. Now I'll see second one. The work done by centripetal force is, centripetal force concept you learned in the previous chapter, uniform circular motion. Here, every body continues to be in state of rest of uniform motion unless a force acts. Newton's first law. In circular motion, the velocity is tangential and the velocity continuously changes from point to point. Was like this, now like this, now in this direction here, like that continuously changes. Why? Because there is a force which acts towards the center, that is centripetal force, FCPF. Here FCPF and velocity directions wise they are perpendicular. If I write this way, perpendicular, which means theta 90 degree, velocity tangential, force radial along the radius. What is work done? Work is force into displacement into cos theta. If theta is 90, what is cos 90? Cos 90 is 0. That's why answer is 0. Total value 0. Whatever be the value of force or displacement, cos theta 90 means, cos theta 0 means total value 0. So no work is done by this centripetal force which is acting towards the center. If work is done, velocity changes, in the sense value of velocity changes, speed changes. It speeds up or slows down. ಹೋಗ್ತಾ ಹೋಗ್ತಾ ಫಾಸ್ಟ್ ಆಗಬೇಕು ಇಲ್ಲ ಸ್ಲೋ ಆಗಬೇಕು ಡ್ಯೂ ಟು application of centripetal force. That doesn't happen. Body continues to move with the same speed, but direction changes. So centripetal force changes only direction, no change in the value of speed. Kinetic energy is a constant in centripetal force. That's why the work done is zero. The next is a person carrying heavy load over his head walks on a level road. What's the work done by? Gravity. Actually, when a person carries load over his head, this is the ground, right? Over his head, he is carrying load with a force. He is applying. What is the weight? Weight acting on the person is weight of the body. That is W. To balance that weight. Okay, right. To balance that weight, he applies a force upwards. The force applied by the person is equal to weight in the vertical direction, vertically up. Whereas walking horizontally, he is walking horizontally. So direction of displacement is horizontal. Here also, in this case also, theta equal to 90 degree, cos 90 0, which implies work done W F dot S, Fs cos theta. When cos 90 is 0, the whole term will be 0, because he is applying force up to balance the weight, not to move it. He has held over his head means it has become part of his body. He is coming along with him. He is applying force to just balance the weight. Gravitational force balance ಮಾಡಲಿಕ್ಕೆ apply ಮಾಡಿದ್ದಾರೆ, not to move it. If he applies to move it, it moves with an acceleration. It moves ahead of him or behind him. ಹಾಗೆ ಅದು is moving along with him. No extra change in velocity, acceleration. He is applying just to balance the weight. That's why work done is 0. Theta is 90. Work 0. That's it, you remember. Next, a man is holding a heavy object at a certain height from the ground. He gradually brings the object down. The work done by the force exerted by the hands on the object is by the hands. He is holding a heavy load, right? Person is holding heavy load with his hands. He now applying a force equal to weight. Weight is acting out down. He is applying force F up. He is applying force F. Which direction? Upwards. When he brings the body down, this is the ground, right? Ground. From this level, displacement is vertically down. The applied force is vertically up. What is the angle between them? Angle between them is 180 degree. So what is cos 180? Here theta 180 implies cos 180 minus 1. So work F into S into cos theta. Cos theta is minus 1, so it is minus F dot S. So negative work. Work is negative. Negative work is done. As displacement is down, force is up. For what he is applying force? To balance the weight. He is applying force up. Gravity is down. Don't get confused with gravity and the applied force. Look at the applied force. Applied force up and displacement down. Angle between them 180. Cos 180 minus 1. That's why the work is negative here. Work done is negative. Option B. That's it. Next one. A person lifts a book from the floor and keeps it. From the floor and keeps it in a shelf which is at a height of 2 meters from the floor. If the time taken in this process is 4 seconds, the work done will depend on what is doing. A person lifts a book from the floor and keeps it in a shelf which is at a height of 2 meter from the floor in the 2 meter there. The time taken in this process is 4 seconds. In 4 seconds, he is lifting it up. The work done will depends on what factors. So it's a bit easier. Now look at the basic definition of work. He is lifting a book which is lying on the floor and shifting it to a shelf, right? Shelf somewhere like this. This is a shelf. He is lifting it to this level, right? The level to which the book has been shifted, displacement h. And to do that, he is applying a force equal to weight of the book, W. Now, by definition, work. What is work? Force into displacement. So, work W, F dot S. F into S into cos theta. Here in our discussion, force applied is weight of the book, that is equal to mg. Displacement is h and theta 0 degree. You notice that weight is acting down, but he is applying force up to balance the weight. The force applied by the man who is doing the work is up, not on mg value only. mg value ne apply ಮಾಡ್ತಾರೆ, but is in the upward direction. That's very important. You have to notice it. ಯಾವ ಕಡೆ upward direction, force is up. mg value ne force is up against mg apply ಮಾಡಿರೋದು, against mg. That's why. And displacement h. So angle theta 0. Therefore, what is work? Work is capital W. F is mg, that is weight, into displacement h into 1. So the terms mg weight and h, mass, acceleration due to gravity, h, are the terms on which work done depends. Let's read the options. Option 1, mass of the book and time taken. Second one, let's come here. Height of the book shelf, height of the bookshelf and time taken. H, he says h and t. There mass and first option. Third option, mass of the book, height of the book and time taken. Height of the book, mass of the book, mht. And the last one, weight of the book and height of the shelf. That's all. Weight of the book is mg, height of the book is h. So work depends on two terms, weight and height, not time term here. Time term appears only for power, that will be denominator. That's why you go with the option D, because it says weight, height. Only mass and height is there, you can write that also. G, mgh. That's why you go with the option D. Is very simple. Okay, next, problem number 6. 200 kg cart. Here, 200 kg cart is pushed slowly up the incline. The work done by the pushing force. In order to move the cart up along the incline to the platform 1.5 meter above the ground. See, this is ground. You just think of the situation. This is the ground, right? You are pushing a cart along the incline to a platform. You are pushing along the incline. You are pushing it along the incline, a cart, right? And that comes here somewhere. What is the height of that? Height h is 1.5 meter above the ground. What is the work done? Whatever be the path followed, students, the work depends on the vertical displacement against gravitational force. That's why work is force multiplied by displacement. The displacement here is mg, work is, force is mg, that is equal to weight of the cart, and displacement is h, that is potential energy. Potential energy between the two levels is itself the work done. This work energy theorem is very easy. Cart mass is 200 kg and acceleration due to gravity, let's take 10. Even if it is mentioned 9.8, let's try with 10 so that you can see some approximated value. See here 294, 2.94, 294 kilojoule. This is kilojoule, and this 300 kilojoule. Sufficient difference between the options. That's why I can try with 10. 15 2s are 30, 300, right? 300, 30, 50, 200. This is 300, 3000 actually. So the value is coming around, not 3000. If you write in kilojoule, it's nearly 3.0 kilojoule. Why kilo? 1000 is kilo. 3 zeros. That's why 3.0. Now answer nearest to this is here in option B. Actually, you have to use 9.8 instead of 10. If you use 9.8, comes around 2.94. But the options are sufficiently showing more difference here. 294, 300, 2.94. Can easily identify the answer. That is 3.0. Okay. We will move on with the next one. Seventh one. A box is dragged along a horizontal floor by a rope which makes an angle 30 degree with the horizontal. The tension in the rope is 150 Newton. The work done in dragging the box to a distance of 10 meters is a very simple application of work density theorem. That's what I told you. You are pulling a box on horizontal floor with a force F. That force here 150 Newton. Force applied is 150 Newton, is moving along the horizontal, making an angle 60. As we discussed in the earlier synopsis part, a component of the force F, that is F cos theta, is doing the work. If you move it through a distance S, then the work done is force into displacement. F into S into cos theta you will use. He says the force is 150 Newton and the distance through which the box is dragged along the surface is 10 meters. 10 meters here. 10 meters. The angle made with the horizontal cos 60. Cos 60 is half. So 2 5s are. So 15 5s are 75. 750 is the value. 750. Option A, right? So this is how you can solve. Now children, we'll move on with the ninth problem. A force F acting on an object varies with distance as shown in the graph here. See here. As force increases, distance varies. A force changes, distance varies, and has been plotted in the graph this way. 1, 2, 3, 4, 5, 6, 7 values in meters and 0, 1, 2, 3 y-axis in Newton. This is the graph showing displacement as a function of, or force as a function of displacement. Force displacement curve. So in this actually you learnt in work power energy chapter. When you plot a graph of force versus displacement, what is the use? A simple example we gave, a constant force not changing pushes a body for a time interval t to a distance x. Let us suppose there is one condition, constant force. You learnt graph for variable force also in the beginning itself in our notes, right? Now it is in the form of a rectangle OABC. If you find area of the rectangle, area of OABC, what is area? It's length into breadth. Length say OC, breadth OA, length is X displacement, and OA is force. What is force multiplied by displacement? This has unit of work, that is joule. That's why it is work done. So area bounded by force displacement curve represents work done. Similarly, velocity time graph, area represents displacement, like that. For different situations use different types of graphs, and they have the area and slope have different meanings. You need to remember them. Here is an example of force versus displacement. You have understood in Fx, F force, X displacement. You can write S also. In Fx graph, area bounded by graph. This is what you have to remember. Represents, right? Graph represents what? Represents work. That is, you always remember work done is equal to area bounded by Fx graph or Fx curve, let's say Fx curve. They have given Fx curve in the graph given here. So this in the form, this part, you start from 0. When the displacement was 0, force was 3. Force 3 Newton actually. It remained 3 Newton up to displacement 3 meters. Then it decreased and reduced to 0 when displacement was 6 meters. So when you cut this graph, he has already shown it by using his dotted line. This is a combination of two areas. One rectangle, the other triangle. It's very easy in calculation. Now, work done W, that is equal to area of rectangle. In fact, that is square into area of triangle. What is area of rectangle? Length into breadth. If I name this, say O, A, B, C, D. What do you write for length? Length is OD into OA, breadth, plus what is area of a triangle? Half into base into height, DC into DB, height. It's very simple. What is OD? OD actually is OD is 0 minus 3 minus 0. 3 minus 0, that is 3. Into OA, 3 minus 0 again, 3. Plus half of, what is DC? DC is actually 6 minus 3. You are just writing the length. Forget the minus in actually. Into, what is DB? D to B. D to B is again 0 level to 3. So it is 3. So the value W is 3 3s are 9 plus 9, 4.5 actually. This part, this actually, okay, just a minute. This is 6 minus 3, 3. 3 by 2, 1.5 times 3. 15 3s are 45. 9 plus 4.5. So it is 13.5 joule. So what do you remember here? Area bounded by Fs curve, force displacement curve, always represents work done. One example for that. Next one, 10th. The change in the state of gas from A to B as shown in the figure 5.4, the work done in the process. You have learned gas laws. There you have learned Boyle's law, Charles law, right? Let us see what he says. Is a pressure versus volume graph, right? Students, you have learned about pressure versus volume graph, Boyle's law. What did you learn there? If you are not, you have forgotten, or if you are not learned in depth about this, you just understand this much. By taking pressure along y-axis, Newton per meter square, and volume along x-axis, meter cube, along x-axis, whatever be the shape of the graph may be like this, or maybe like this, a horizontal line parallel to volume axis, pressure is not changing, that you call isobaric process. Any type of graph, The area bounded by PV graph, pressure volume graph, always represents work done. Represents work done. How do you explain it? How? So very easy. I'll consider this simple case where pressure is constant, volume is changing. Volume increase from 0 to some value here. So what is the shape now? OABC. The shape is a rectangle. Why you consider rectangle both the cases? A simple example, that's it. Now, whatever we discuss for this applicable for all different types of graphs, that's it. So now what is area? How do you find area? Area under graph, which is graph here AB, curve actually, a straight line. Area under graph AB is a rectangle. Area of rectangle. What is area of rectangle? Area of rectangle is, that is area of the graph OABC. Now, what is area of OABC? As this rectangle, length into breadth, length OC into A. From O to A, some pressure, from pressure P till here. There is some volume V, 0 to V. P minus 0, V minus 0. That way you think. So it is P minus 0. You know how to find the distance. P minus 0. This value V minus 0. Instead of writing V minus 0, you can just write V. PV, that's it. Pressure into volume. This is work actually, work. How do you know it is work? You write down the unit. What is unit of pressure? Newton per meter square. What is unit of volume? Meter cube. So 1 meter remains here. 2 meters get cancelled, 2 term. So you are left with 1 Newton, 1 meter. What is Newton into meter? Joule, unit of energy or work. That's why you remember, students. That's why you remember always the area bounded by pressure volume graph is a work done during that process, changing volume from 0 to V by changing pressure. Similar to force displacement graph. Force displacement graph area, work done. Pressure versus volume area, work done. So if you have this much in mind, you can easily solve this problem. In this problem, you have a graph that is starting from A. Already A is at pressure 110 power 5, volume 1. A to B, C to D, D to B. This way, the value is changing. There are two areas you can easily notice. See here, I shade this. This shape is called a trapezium. This shape is called a trapezium. I shade another one. Look here. What is that? This part here. So this is a rectangle, simple rectangle. FABE. FABE is a rectangle. ACDB is a trapezium. ACDB is a trapezium. So you can easily find the area bounded by them. The values have been given already. So very easy now. See, what is work done according to our discussion? Work done is equal to area bounded by pressure versus volume graph. So work done that equal to, there are two areas, area of rectangle FAB plus area of trapezium, trapezium, geometrical shape, trapezium ACDB, that's it. So what is area of a rectangle? Area of rectangle is length into breadth. Length say FE into breadth FA. Plus what is area of a trapezium? You have forgotten? No. Half into sum of parallel sides into perpendicular distance. Sum of parallel sides are AB and CD. AB parallel to CD. So parallel sides are AB and CD, their sum you have to find into perpendicular distance. What is perpendicular distance? From here to here, look here. DCG, C to G, he has marked already. This is the, between these two lines, this is the perpendicular distance. That is CG. Okay. W, what is FE? F to E, 7 minus 1. 7 minus 6 in fact. This is position 7. This is 1. 7 minus 1 into, what is FA? FA is 1 because this is 0. 1 minus 0 is 1. 10 raised to power 5 plus half of, what is AB? AB again, 7 minus 1. What is 7 minus 1? 7 minus 1, 6. You can directly write. You can easily notice. That is 6 here. Similarly, this is 7 minus 1, 6 plus, what is CD? CD. D value 5, 5 and C value 3. What is the difference between them? 5 minus 3, 2 into perpendicular distance CG. Look here, perpendicular distance is height along y value. 1 10 power minus plus 5 to 3 10 power plus 5. What is 3 minus 2? 3 minus 1? 2. 10 to the power 5. Once again you observe here, the position of G is 110 power 5. Okay, 110 power 5. And position of C on y-axis is 310 power 5. 3 minus 1 is 2. 2. It's enough. 6 10 power 5 plus 2 cancels. 8 10 to the power 5. What is 6 plus 8? 14. 10 to the power 5. So the option D, joule, SI unit, joule. That's it. You can identify answer. Now 11th, the slope of potential energy versus position represents potential energy versus position. Students, according to our work energy theorem, work nothing but energy, either potential energy or kinetic energy. Change in potential energy, kinetic energy. So capacity of doing work itself is energy. Capacity of doing work is itself energy. That's why if I denote work by W, potential energy by U, they are equivalent. A graph of work versus displacement implies graph of potential energy versus displacement. Take potential energy or work along y-axis and displacement along x-axis. You plot a graph. If there is a graph like a line, any shape, a curve or a straight line, there are different situations will come across. For different examples, different types of graphs will be there. ಈ ಗ್ರಾಫ್ನಲ್ಲಿ as displacement increases, work also increases. There are examples for such situations will come across. ಈಗ ಬರೀ ಇಷ್ಟು ನೋಡ್ಕೊಂಡಿರಿ. ಈಗ he says, if I find slope, what is slope for any straight line like this or a curve? Slope is a triangle, constructing a triangle like this. From this, what do you find? We find, see, if I draw a vertical line, this is displacement axis, x-axis, over which let us mark this is position S1 or displacement S1, 0 ಇಂದ ಇಷ್ಟು ದೂರ ಹೋಗಿದೆ. ಆವಾಗ ವರ್ಕ್ ಡನ್ ಈಸ್ ಸೇ ಸಮ್ W1, corresponding energy is U1. If we increase displace from S1 to S2, then the corresponding work done is some U2. This is how we analyze the graph. When displacement changes from S1 to S2, corresponding work energy changes from U1 to U2. Now there is some angle formed. This is opposite side and this is adjacent side. Now slope is opposite to adjacent. Ratio opposite to adjacent is actually tan theta. Slope is tan theta. Why we think like this? Here there is an option to calculate change in y value for a corresponding change in x value. Many situations we are interested in knowing what is the change in the value of y for a corresponding change in value of x. We call it rate of change. Where change in the value, if I find this change in the value of u, potential energy, for a corresponding change in displacement, position. Right? So, what is the SI unit here? If I do that, this change in, if I write delta, you read change. change in potential energy to corresponding change in displacement. If I write unit or find unit, what is potential energy unit? Energy is joule. Divided by distance, meter. What is joule? Joule is Newton meter divided by meter. So one unit term cancels. So unit is Newton. What is Newton? Force. That's why when you find slope, you are finding the ratio energy to displacement. Because what is energy? Capacity of doing work. What is work? Force into displacement. If I divide displacement U by S or W by S, you are left with force. That's why ratio of work to distance or potential energy to distance is force. That is found by using but that is found by finding slope in work versus displacement graph. Work displacement graph ನಲ್ಲಿ slope find ಮಾಡಿದಾಗ that has a meaning of force, because slope is change in y value for a corresponding change in x value, which is work by displacement. That's all. So our answer must be option A. This is how you have to think, students. Children, next we'll see some problems related to another term, that is power. What is power? You have learned power as rate of doing work. The rate with which the work is done, because sometimes just work done not sufficient to explain a particular phenomenon. It requires something else, something more to understand about the work, that is power. Power is rate of doing work, is work done divided by time, work done divided by time. So power P, W divided by T. For W, that is work, you can write force dot displacement, or you can write Fs, S cos theta, Fs cos theta divided by T. If I use this, I can write P F dot S divided by T. If I divide this time to displacement, you have one more term, displacement by time. Rate of displacement is velocity, so I can write F dot V. So power is also written as dot product of force and velocity. So Fv cos theta will be quite useful for our calculations further. The rate of doing work is power. Now we'll see some important applications, some 2-3 examples, and we use this power in along with energy. Energy we'll see next. Let's read the first problem in this direction, that is 31. Let's see 31. It is easy to climb mountain in a zigzag path than climbing up straight, because if you climb up, there's a huge mountain, right? So normally the mountain roads will be like this one here, like this. They move around in helical path like this, right, and reach the top. Instead of moving straight up, we can make a road straight up, but instead of that, you can see a helical path. Why? Because power. What is power? It is work divided by time. Power is work by time. Now let's think this way, student. This is the base of the hill. From this level to this level, height remains the same. Whether you choose this helical path around the hill or the straight uphill straight path, almost straight. E path choose ಮಾಡಿ or this path. For both the paths, the height remains the same. Therefore, the work, what is that? Force into displacement divided by time. What's force? For example, you are climbing up, you are doing work against your gravitational force, that is mg dot displacement h divided by t. Whether you choose, let us call this path helical path 1 and the straight path 2. Whether you choose path 1 or path 2, numerator term is same, but the thing that matters is denominator. Power inversely proportional to time. If you choose straight path, you move in lesser time. Curved path, you require more time. The same work is done for a longer period, you get strained less. So power inversely proportional time. Time is more, power less. Rate of doing work is less. So it is easier. You feel easy to climb up taking more time. Time is not the constraint. Whether you reach in 1 hour or 3 hours doesn't matter. Finally, you go to there, to the top of the hill. That is the point. Of course, in the curved path, this helical path, you need more time, but power required is less. Power required is less. That's why it's easier to climb in a zigzag path like this, helical path. Option C. Now let's move on to the next one, that is 32nd. A motor pumps 300 kg of water per minute, 300 kg per minute from a well of depth 20 meters, 20 meters deep ಇದೆ. And delivers it to a height 20 meter. 20 ಮೀಟರ್ ಡೀಪಿಂದ ಆ ಹೈಟಿಗೆ ತೊಗೊಬರ್ತೀರ ನೀವು. ಅಂದರೆ ಹೈಟ್ 20 ಮೀಟ್ರಿಂದ ನೀವು ಲಿಫ್ಟ್ ಮಾಡ್ತೀರ ವಾಟರ್ನ. Then the power of the pump is, power of the motor pump is, you have to find power. The simple idea is, what is power? Power is rate of doing work, W divided by T. What is the term W? W is actually force into displacement. Force into displacement divided by time. What is force? Force is the weight of the water. Some amount of mass is lifted up. If m is the mass lifted up per unit time, then m into g, m is mass of that quantity lifted up from the well. R mass into g is weight. And yes, I have removed this vector symbol because theta equal to 0 degree here. What is cos 0? Cos 0, 1. Why? Because you are moving the mass up straight. The displacement is up, force is up. Of course, gravity is down, but you are applying a force equal to gravity up. So, displacement to force ಎರಡೂ ಅಪ್ ಇದೆ. ನೀವು ಏನು ಯೋಚನೆ ಮಾಡ್ತೀರಾ, ಯೂಶ್ವಲಿ ದಿಸ್ ವೆಲ್, ಫ್ರಮ್ ದಿ ವೆಲ್ ಯು ಆರ್ ಪುಷಿಂಗ್ ವಾಟರ್ ಅಪ್. ನೋಡಿ, ವಾಟರ್ ಎಕ್ಸ್ಪೀರಿಯನ್ಸಸ್ ಫೋರ್ಸ್ ವೆಯ್ಟ್ ಡೌನ್, ರೈಟ್? ಬಟ್ ಯುವರ್ ಫೋರ್ಸ್ ಇಸ್ ಆ್ಯಕ್ಟಿಂಗ್ ಅಪ್, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ಆಲ್ಸೋ ಅಪ್. ಅವೆರಡು ನೋಡಬೇಕು. ಸೊ ಆ್ಯಂಗಲ್ ಥೀಟಾ 0, ಕಾಸ್ 0, 1 divided by T. That's it. Now, what is the time here involved? Time is not 1 minute. Time is 1 minute. So, what is power? 300 kg of water is lifted in 1 minute. So, 300, 1 minute interval let's take. G 10, 9.8, 10. Let's find it using 10. Let's then identify the answer. Into displacement. How much distance you are moving it? 20 meter. 20 meter from the... So, 20... here well depth 20 meter and deliver it to a height 20 meter. So what do you think here? Totally, what is the height? You have to think like this. See, this is well. What is the depth? It is ground. Depth of the well is 20. Water is here somewhere. Depth deep agide inolagade. Water delivery ilinda lift ಮಾಡ್ತಾರೆ from 20 meter depth. And you are delivering it to a height 20 meter from this. Idu 20. What is total height then from here to here? Total height is till here 20 plus 20. Total height to which water is lifted up is 40 meters. So you have to take 40 divided by the total value. Time is 60 minutes. Now you can easily find the value that comes around. Here you can simplify it. Here he has used 9.8. I have used 10. 9.8 actually. That's term missing. So you remove 1 0. It's gone. So 2 2s are 2 3s are 2 2s are 2 3 1s are, right? That is 1000. That is around. Is coming around 20,000. P 20,000 watt. Joule per second, that is watt. So your answer is coming around P 20,000 means kilowatt, 20 kilowatt. We are getting 20, but here 19.6, 19.9, he says 1.96, 19.6, 0.98, 3.92. You can go for the answer 19.6 because we used 10 instead of 9.8. If you use 9.8 directly, you will get 19.6. Thus, you can approximate the answer. Instead of using 9.8 and doing little bit complex calculation, directly use 10. Then you search for the nearest answer. If all the options are very close to each other, then you use 9.8 and multiply, divide whatever you want to, right? Next is very simple, almost similar. That is, a human heart pumps 4 × 10⁻³ meter cube blood through arteries per minute. Time interval is 1 minute, 60 seconds. At a pressure 13 centimeter of mercury. If the density of mercury is 13.6 10⁻³ kg per meter, 13,600. The power of the heart is, you have to find power. It's almost a very similar calculation. Yes, children, here in this problem, the heart pumps blood with value pumps 4 × 10⁻³ 4 × 10⁻³ meter cube. What is this? This is volume per minute, time per minute. This volume, this much blood is pumped per minute. Per minute means 60 seconds. At a pressure P is equivalent to 13 centimeter of Hg. You know pressure formula, that is equal to rho gh. So 13 centimeter of mercury means in barometer, if that pressure equivalent to pressure exerted by 13 centimeter of mercury. So use atmospheric pressure formula, rho gh, rho density of mercury, g acceleration due to gravity, and h height, that is 13 centimeter, you write in meters. That's it. Now what you have to find? You have to find power. What is power? Power is work divided by time. Same formula. What is work? According to our graph, previous graph, pressure into volume is also work. So in this case, you have to use pressure into volume. What is pressure? Rho gh into V divided by T. Now you make a substitution. That is density of mercury 13.6 10⁻³ into G 10 into height mercury column, that is 13 centimeter 10⁻⁻² into volume 4 × 10⁻³ whole divided by 60. Now you simplify it, you will get a value. Yes, the value comes around 1. You just approximately, I have found this 1 comes around 1. So nearest answer to 1 is 1.15 watt, not HP, because 1 HP, 740 is 1 HP, horsepower, 746 watt. So to write in HP, you have to divide by 746. So that is not there here, and 2.3 not an option. This is also not an option. So option is 1.15 watt. That's all. We'll move on, students.